Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 11, Lesson 4, Modeling with Systems of Equations. So we've now seen three separate methods for solving systems of equations: graphically, by substitution, and by elimination. Today what we're going to be doing is modeling a variety of different types of problems with systems and then deciding which of the two methods, either substitution or elimination, we will use to solve. We're not going to be solving any of these modeling problems using a graphical solution. It's all going to be substitution and elimination, and we'll talk a little bit about strategies to determine which one of them is the best way to go. For now, let's jump right into the modeling. All right, here we go. We now have multiple methods for solving systems of equations. We can model many problems using systems and then pick the method that makes the most sense to solve the system. Okay, so let's take a look at one that doesn't connect to real life so much, but it is pretty easy to set up the system. Exercise number 1. The sum of two numbers, a and b, is equal to 19. The number a is 4 more than twice the number b. Letter A asks us to write a system of equations that models the information given, and then in B we'll solve this system by substitution. All right, well, I'd like you to pause the video now and try to actually just create the system that models the two pieces of information they've given us. Well, the first piece of information is actually pretty easy, right? The sum of the two numbers is 19. Awesome. So a plus b is equal to 19. Now, that's an easy one. The other piece of information is the fact that a is 4 more than twice the number b. We can literally translate that as a equals twice the number b plus 4, right? I really don't want to do 4 plus 2b, by the way. They are the same thing, 4 plus 2b and 2b plus 4, but only because addition is commutative. Truly, 4 plus 2b would be 2b more than 4. That sounded really, really weird. But 4 more than twice b is really 2b plus 4. It still sounds strange. Anyway, let's take a look at letter B. Solve this system by substitution. Now, in this problem, I specifically said use substitution, but let's talk about why that makes sense as opposed to using elimination, right? Substitution makes a lot of sense in this case because in the second equation, right, the a is isolated. It's all by itself, so it's easy enough to take the 2b plus 4 and substitute it in for the a in the first equation. So why don't you go ahead and solve this system in letter B by using the method of substitution. All right, well, here we go, right? We're going to take our 2b plus 4 and use the principle of substitution to put it in for that a in the first equation. Now, as always, what substitution does and what elimination does is it gets rid of one of the two variables. This now equation only has b in it, so I can take 2b and 1b and combine them to be 3b. I get 3b plus 4 is equal to 19. I can now subtract a 4 from both sides. Gives me 3b is equal to 15. I can now divide both sides by 3, and it gives me b is equal to 5. Okay. Now, as always, it would be easy to make the mistake of just saying, hey, I got my answer, I'm going to move on. But I need not only the answer to b, I also need the answer to a. Which one of these should I actually put it into? It really doesn't matter. Whichever one's easier. I'm going to actually substitute it into the second equation because the second equation is like, hey, this is what a is equal to, right? Here it is, a is equal to. So, just reserve a little space here. A is equal to 2b plus 4. So a will be equal to 2 times 5 plus 4. 2 times 5 is 10. And 10 plus 4 gives me a equals 14. Now remember, a nice check, or maybe a nice half check if you will, is to take those two values and check them in the equation you didn't use to produce that second value. Specifically, if I took the 5 and the 14 and I put them into this equation, 5 plus 14 equals 19, that's true. So it's a good check. Now in this particular problem, there's no real kind of physical real-world context. It's just about these two magical numbers that sum to 19, where one number is 4 more than twice the other number. Let's now take a look at a classical system situation out of geometry. All right, here we go. Exercise number 2. The rectangle pictured below has a length given by capital L and a width given by capital W. Its perimeter is 84 feet. Its length is 6 feet less than 3 times its width. Letter A asks us to model the information given in this problem with a system of equations. All right, great. I'd like you to pause the video and see if you can model all the information given in this problem with 2 equations, right? Both of those equations are going to involve W and L. Pause the video now and see what you can do. All right, well, let's first take a look at the fact that we know that its perimeter is 84 feet. Well, how do you calculate the perimeter of any rectangle? Well, you calculate it by taking twice the width plus twice the length, and that's the perimeter. So twice the width plus twice the length must be equal to 84. Now, if you have W plus L equals 84, that's a little problematic, right? Because you don't find the perimeter by taking this side and adding it to that side. You got a W plus a W, 2W, an L plus an L, 2L, and when I add them together, I get 84. Now, the other piece of information they give me is the fact that its length is 6 feet less than 3 times its width. Now, here's where the order really matters. Now, we talked in the last problem, it didn't really matter if you had A equals 2B plus 4, A equals B plus 2B, A equals 4 plus 2B. In this problem, this is critical. The length is 6 feet less than 3 times the width. It must be this. It cannot be 6 minus 3W. If you have 6 minus 3W, that is completely different than 3W minus 6. But now we have our system, and we can solve it. And we're going to solve it by substitution again, right? Because our second equation has the length isolated all by itself. So I'd like you to now pause the video and in letter B, find the length and the width of this rectangle by solving this system. All right, we want to be real careful. Right, we're going to take that 3W minus 6 and we're going to substitute it into that first equation for L. But remember, we've got to multiply the entire 3W minus 6 by the 2. All right, that means we've got to do a little bit of distributive property here. So I'm going to get 2W plus 6W minus 12 is equal to 84. All right, now we have only W's. 2W plus 6W is 8W minus 12 is equal to 84. Whoops, 84. Move this out of the way. You will probably want your calculator for a little bit of what we do today. So if you don't have it out yet, maybe now would be a good time, or maybe now wouldn't be a good time. But either way, I get 8W is equal to 96. I'm going to divide both sides by 8, and W is going to be 12. 96 divided by 8 is 12. Okay, I've got my width. It's 12, specifically 12 feet here. I need my length. Of course, as always, I can take my width and I can substitute it into this equation or this equation to get the length. I'm going to put it into the second equation because it's relatively easy to use. Length is 3W minus 6. 3 times 12 is 36 minus 6, and now my length is 30. So I've got my length is 30 feet, and my width, should always include units, is 12 feet. And that is a classic scenario where systems actually come up a lot, where you've got some kind of condition with the perimeter. Sometimes you have a second equation that relates to the area of the rectangle, and then you combine the two to help you solve the system. Let's take another look at another one that involves perimeter. Okay, here we go, exercise number 3. A different rectangle has a perimeter of 144 feet. The difference between its length and width is 12 feet. Set up a system of equations based on this information and solve it by elimination. Assume that the length is the longer dimension. All right, Well, the first thing I'd like you to do is pause the video and set up the system. Then we'll talk about the system, and then we'll have you solve it by elimination. But pause the video first and just simply try to model what they've told us using a system. Well, again, the first piece, which is the fact that we have a perimeter of 144 feet, that is going to be just 2w, actually maybe I'll do it as 2L plus 2W is equal to 144. Now, they also tell us the difference between its length and width is 12 feet, where the length is the longer dimension. That means L minus W is equal to 12. Okay, and there's our system, right? 2 times the length plus 2 times the width is 144, and the length minus the width equals 12. Now, did you notice I started writing down 2W plus 2L is equal to 144? That wouldn't have been wrong, but I kind of like having the L and the W in the same order in both equations because now I'd like to solve by elimination. Now, we looked at the method of elimination in the last lesson, right? And of course, you did it on your homework. If I were to add these two equations right now, nothing would eliminate, right? I'd have 2L plus 1L, which would be 3L. 2W plus negative 1W would be 1W, and then 144 plus 12 would be 156. Either way, nothing would eliminate. So I need to get something to eliminate, which means I need to multiply one of these equations by something that will then have additive or produce additive opposites that will cancel. I'd like you to pause the video and see if you can solve this system by using elimination. All right, well, what I'm going to do is I'm going to take this second equation and I'm going to multiply both sides of the equation by 2. All right, now when I do that, what it's going to give me is it's going to give me 2L minus 2W is equal to 24. I'm now going to write down the first equation again, 2L plus 2W equals 144. And now I can solve it by elimination, right? Because these W's are going to cancel when I add. 2L plus 2L is 4L. 24 plus 144 is 168. And this is, I think I can still do this one in my head. 168 divided by 4 is 42. So the length is 42 feet. Okay? Now, obviously, I still have to figure out what my width is. I need to just take that 42 and substitute it into one of these two equations to figure it out. I think I'll go with the first equation. Okay, so that's going to give me 2 times 42 plus 2 times the width is equal to 144. Give myself a little extra space here. I'm going to have 84 plus twice the width is 144. Subtract that 84 from both sides. All right. That's going to give me 2 widths is equal to 60. Divide both sides by 2, and my width is going to be 30 feet. All right, and that's it. Now, of course, the big difference between this problem and the last problem was in this problem, in both equations, the variables were on the same side of the equal side, so it made a lot of sense to do elimination. In the previous problem, and even the one before that, one of the two equations in our model had a variable isolated, so it made more sense to do it by substitution. All right, let's keep going with our modeling. Let's see what we have in number 5. Exercise number 4. A cafeteria has tables that sit 4 people and tables that sit 6 people. There are a total of 12 tables and enough room for 56 people to sit. Let F be the number of 4-person tables, and let S represent the number of 6-person tables. Letter A. Could there be 10 4-person tables and 2 6-person tables justify? Well, let's talk about that a little bit, right? So here we've got a more complicated scenario than just kind of our perimeter, let's say. Now, the question is, could there be 10 4-person tables and 2 6-person tables? Well, one thing right away is if I've got 10 of the 4-person tables and 2 of the 6-person tables, I have a total of 12 tables. And that's a good thing, because that's what they told me. I mean, had they said, like, I had 5 of these and 4 of these, well, that couldn't be right, because that would be only 9 tables, and they told me they had 12. The question is this enough so that we sit 56 people? Pause the video and see if this could be the sort of solution to this system. See what you get. All right, well, let's take a look. You know, to figure it out, I might say, well, I could take 10 times 4, right? Because I've got 10 4-person tables, okay? And maybe add to it 2 6-person tables, and let's see what I get. I'd get 40 people that could sit at those 4-person tables, 12 that could sit at those 6-people tables. That would give me 52. But they tell me I have enough for 56 people. So no, right? That is not correct. All right, not correct. So we need to set up a system to try to model what they've given us so we can solve it and figure out how many of each table we have. So let's take a look at letter B. Model the information given using the variables S and F. Okay, now, really important to understand, right? The S and the F represent the number of 6-person tables and the number of 4-person tables. It's not how many people are sitting at the table. It's literally, oh, you know, I've got like in this case, I was talking about 10 4-person tables and 2 6-person tables. So in this particular, you know, part A, F would have been 10 and S would have been 2, and it wasn't going to get the job done. So I'd like you to try to set up a system of equations that models all the information they gave us. Don't try to solve it, just see if you can model it. All right, well, let's talk about the easy part. We know that if S represents the number of 6-person tables and F represents the number of 4-person tables, then when I add those two together, S plus F, I've got to get 12. Right? The number of 6-person tables plus the number of 4-person tables has to be 12. But how do I get the 56 involved? Well, think about it this way. How could I calculate the number of people sitting at the 6-person tables? Well, I'd take all the number of 6-person tables I have, and I'd multiply by 6, right? And that would tell me how many people are sitting at the 6-person tables, all of them together, right? Not just at one of them. At one of them, there's 6 people, but at all of them, there's 6 times the number of 6-person tables. Now, if I wanted to know the number of people that sat at the 4-person tables, I would do the same thing, but multiply by 4. And if I would want to know the total number of people that could sit down, I would add those together, and I know that must be 56. And there is my system. The number of 6-person tables plus the number of 4-person tables has to be the total number of tables, 12. If I take all the people that are sitting at the 6-people tables, all the people sitting at the 4-person tables, add them together, that has to be 56. All right, let's take a look at letter C. Solve the system of equations in B using elimination. Check the reasonableness of your answer. All right, we'll talk about what that means in a bit. But what I'd like you to do now is pause the video and solve this system using elimination. All right, well, you had a choice to make, right? Do you want to eliminate the S? Do you want to eliminate the F? Either one works just fine, right? Now, a little bit tricky, I'm going to have to multiply both sides of this equation by a negative number at this point, right? If I want to eliminate the S, I would multiply both sides by -6. If I want to eliminate the F, I would multiply both sides by -4. And I think that's the way I'm going to go. All right, so first, let me just come down here and let me rewrite the system. All right, so what I'm going to do is I'm going to take this and I'm going to multiply both sides by -4, okay? And that's going to give me the following equation. -4s minus 4f is equal to -48. And then I'll have 6s plus 4f is equal to 56. Again, let's just pause right here so we can talk about this. Again, I just need to be careful about multiplying both sides by -4. I have to distribute the -4 so that both the S and the F get multiplied by it. And then of course, very important, I can't forget to multiply the other side of the equation by -4. But the beautiful thing now is when I add them, these two are going to cancel out, right? And when these two cancel out, I'll then have -4 plus +6 is going to be 2S. Here, -48 plus +56 is going to be +8. And now I divide by 2 on both sides, and I get S is equal to 4. And again, don't forget what you just found. What we just found is that there needs to be 4 6-person tables. I know that's a little bit confusing, but there it is, 4 6-person tables. Now I want to figure out how many 4-person tables there are. Well, I love this first equation, right? Because it just says the number of 6-person tables plus the number of 4-person tables is equal to 12, right? So I mean, I almost don't need to substitute at this point, right? That's easy enough to see that the number of 4-person tables must be 8. Now, that whole check the reasonableness of your answer, well, that's simple. Do I have 12 tables? Yep, 4 plus 8 is 12, right? Can I sit 56 people? Well, if I can, then I'll have those 4 tables times 6 plus those 8 tables times 4. I could always just take my calculator out really quick to do that. 4 times 6 plus 8 times 4, and I get my 56 people. So that really is doing a check, right? Now, by the way, in terms of reasonable, these are reasonable. Think about some answers that wouldn't be reasonable. Anything with a decimal wouldn't be reasonable because we're talking about the number of tables. You're not going to have 3.5 6-person tables or 4.25 6-person tables. Also, if either one of these variables had turned out to be negative, that wouldn't be reasonable, right? What does it mean to have negative tables? You know, you can't have that. It just can't. You can have a negative person, but you can't have a negative table, I don't think. Anyhow, let's keep going on. Let's do one more problem. Exercise number 5. At a pool concession stand, Alex buys 2 hamburgers and 1 soda and pays $11.75. His friend Ryan then buys 3 hamburgers and 2 sodas and pays $18.75. Let H represent the price of 1 hamburger, and let S represent the cost of 1 soda. Letter A, could 1 hamburger cost $4 and 1 soda cost $2.50? Justify. Well, play around with that a little bit. Could the hamburgers cost $4 each and the sodas cost $2.50 each? Just play around with the information they gave you in the problem and see whether or not those could be the unit cost of the hamburger and the soda. Well, let's check it with just what Alex bought. And then if it works for Alex, we might want to also check it with what Ryan bought, okay? So what does Alex buy? Alex buys 2 hamburgers, right? So what are we saying? A hamburger costs $4? So 2 times $4 plus and 1 soda, right? And we said a soda costs $2.50. That's going to be 8 plus $2.50, and that's going to be $10.50. Now, what did they say that Alex spent? Alex spent $11.75. So, no. Nope. We don't even have to check Ryan, right? Because we know that if the hamburger costs that much and the soda costs that much, then Alex would have only paid $10.50, but we're told that Alex pays $11.75. All right. Now we want to try to model the information with a system of equations. So, pause the video now. Keep in mind your variables are H, and that's the price of 1 hamburger, and S, and that's the price or the cost of 1 soda. Pause the video now and see if you can model all the information they've given with a system of equations. All right, well, this is kind of cool, right? Think about how you would actually calculate how much Alex spent. Alex, then we'll get to Ryan. If you wanted to calculate how much Alex spent, right, you'd take the fact that he bought 2 hamburgers and you'd multiply it by the price of a hamburger. And then you'd add to it the price of 1 soda. If you want to put a 1 in front of that S, you can, but you don't need to. And you'd set that equal to $11.75, right? So that would be the equation that would model sort of Alex's situation. But then Ryan comes along. Ryan wants more food, right? Ryan buys 3 hamburgers, so that'll be 3 times H, and 2 sodas, right? And Ryan pays $18.75. And that is our system. And we're going to solve that system in letter C by elimination because the variables are on the same side of the equal sign. So I'd like you to do that. In letter C, I'd like you to take these 2 equations and I'd like you to solve the system. All right, so what's going to be the easiest variable to eliminate? There's going to be a lot of negatives flying here, but that's okay. It's going to be easiest to eliminate the s's because I could multiply this first equation by -2 to give me a -2s there that will cancel the positive 2s there. So let's do that. I'm going to do this, multiply this equation by -2, and I've got to do that on both sides. Okay, and that's going to give me, when I distribute, it's going to give me -4h minus 2s, and there is nothing wrong at this point with pulling this out and saying, well, I'm going to have -2 times 11.75 gives me -23.5. All right? Now, I'm going to just take this equation and bring it down here, because why not? Now I can add these 2 together. Now we have to be careful here. I have a -4h and a positive 3h, and that's going to leave me with a -1h. These 2 are going to cancel. And again, nothing wrong with taking your calculator at this point and doing -23.5 plus 18.75, and that gives me -4.75. All right, let's pause just for a moment before we finish this out and figure out the price of a hamburger. I hope this logic is really easy for you. If -h equals -4.75, then positive h equals positive 4.75. So a hamburger, right, is $4.75. And as always, to figure out the price of a soda, I can take that and substitute it either into this equation, or this equation. I think I'm going to go with the 2h plus s equals 11.75. So 2 times 4.75 plus a soda is equal to 11.75. Okay, maybe I take my calculator out and I do 2 times 4.75, and that's going to be 9.50. Plus that soda equals 11.75. So now I just need to subtract off 9.50 from both sides. And I find the price of a soda is $2.25. All right. And that's it. Now this one's a little bit trickier because, you've got a lot of negatives and you need those because you really want to eliminate the s. So in order to do that, I've got to get a -2s here, which then gives me a -4h and a -23.5. But that's it. You'll do a lot more modeling with systems of equations when you get into Algebra 1, hopefully next year. Let's wrap this up. So today what we did is we saw a variety of different problems, some of them just like with numbers, the sum of 2 numbers, the difference of 2 numbers. We also saw some geometric applications, including things that had perimeter in them. And then we saw a couple classics, right, that had like prices in them and stuff like that. You got the 4-person table, the 6-person table, and it's really helpful in all of those to think how you would calculate things if you actually knew the values of the variables. That's why in both of those last 2 problems I said, could these be the number of 6- and 4-person tables? Could these be the price of a hamburger and the price of a soda, right? That way it forces you to think about how you actually would calculate things if you knew the actual numbers, and then that allows you to set up the system a lot easier. Now, systems of equations are really critical. You will see them as you move forward in almost every math class and in a lot of science classes. They're used a lot in physics, a lot in chemistry. They're one of the most critical things in all of mathematics. But for us, that's it, right? This is actually the last lesson, at least at this point in time, in NGen Math 8, which means it's the last lesson in our middle school series of videos. I want to thank you for joining me for NGen Math 8, and I want to remind you, as always, until Algebra 1, keep thinking and keep solving problems.